Welcome to the Yaka Digital Network. If you look around your home or school compound, things might seem perfectly normal, but there are often biological threats hiding right out in the open. A single patch of stagnant water after a rainstorm or a small pile of uncovered rubbish is actually a thriving habitat for danger. These environments attract organisms we call vectors, insects like mosquitoes and houseflies that multiply in the dirt and carry invisible germs from place to place. When human waste and daily rubbish are left unmanaged, these vectors pick up those germs and transmit illnesses directly to humans, including cholera, typhoid, and dysentery. Sanitation is our primary defense system. By managing our waste properly, we build physical barriers that protect our bodies from severe sickness. To build those barriers, we have to answer a basic question. How exactly do invisible germs travel from human waste into a healthy person's body? This diagram outlines the main routes of transmission. Epidemiologists call it the F diagram. Starting from human waste at the center, germs can travel through fluids, like contaminated drinking water, or across our fingers when we skip washing our hands. The paths continue branching. Germs hitch a ride on flies, which land on waste and then walk on our stored meals. They also contaminate our fields or food when crops are grown in polluted soil. Eventually, all four of these pathways, fluids, fingers, flies, and fields, converge on a new, healthy human host. Stopping an outbreak means designing specific physical and behavioral roadblocks to cut off every single one of these pathways completely. The first major barrier we use targets both flies and fluids. This is the safe disposal of human waste using a ventilated improved pit, or VIP latrine. Looking at this cross-section of a VIP latrine, we can see exactly what happens below ground. Deep inside the pit, bacteria break down the waste without needing any oxygen, a natural process called anaerobic digestion. This steadily reduces the solid waste volume over time. Above ground, the physics of the structure do the rest. Air flows down the drop hole and up the tall vent pipe, carrying foul odors away. When flies follow that smell up the pipe, they get trapped, bouncing off a screen at the very top so they can never return to land on our food. We construct these latrines using local resources like timber and mud, ensuring the pit is dug far away from any underground drinking water sources. A properly built VIP latrine functions as a sealed biological vault. It neutralizes the waste and physically severs the link between germs and the community. Once a person leaves the latrine, the fingers pathway becomes the immediate threat. We need a strict hygiene barrier before anyone shakes hands with friends or handles a meal. This illustration shows a tippy-tap hand-washing station, built entirely from local materials. You need a pierced yellow plastic jerry can suspended between wooden poles with strong twine, along with soap and a foot lever. Take a look at the base of the structure. Why is a wooden foot lever such an essential part of this device? By pressing the foot lever, clean water trickles out automatically. You never have to touch the plastic container with dirty hands, washing germs away safely. Mandatory hand washing with soap after using the latrine creates an unbreakable roadblock for the fingers pathway. Beyond personal hygiene, we manage the entire school compound and village fields to destroy vector breeding grounds before they form. On the left side of this diagram, we see how organic kitchen waste, like banana peelings, decomposes. By exposing this waste to oxygen, a biological process called aerobic composting turns the scraps into nutrient-rich garden humus. On the right, we have dry, non-biodegradable rubbish like plastics and dry leaves. These items must be collected and safely deposited into a deep, covered rubbish pit or incinerated, keeping them far away from our crops. Maintaining the environment also requires physical labor. By rapidly slashing down tall grass around the compound, we eliminate the dark, damp hiding places where snakes and malaria-carrying mosquitoes rest. Correctly sorting waste and physically clearing the bushes destroys vector habitats before pests can multiply. All of these individual barriers, the latrines, the rubbish pits, and the tippy-taps, require spatial planning so they do not interfere with each other. This top-down map of a school layout shows the critical rule of sanitation planning. Latrines and rubbish pits must always be placed at a safe, downhill distance away from our clean drinking water sources. Community-led total sanitation is based on a simple biological reality. If one household ignores hygiene, germs will travel through the water and the flies to put the entire village at risk. Neighbors must work together, mapping out local risks and building these physical barriers for every home. with the goal of achieving a fully open defecation-free village. True sanitation requires a united effort to transform dangerous environments into thriving, healthy communities. To keep learning how to protect your health, visit us at yaka.cc for more lessons.